Hello everyone, welcome to my new video or lecture where we are going to learn about electrical voltage. So for example, in classical physics we had potential energy, and for example, let's say we have two glasses of water here and here, and they are connected with a tube like this, and they're on the same height. And when you fill it with water, you'll see that there won't be any flow of water when they are on the same height. But when let's put this glass of water higher. And now you can see, if you fill this water here, if you fill this here, I'm sorry, then you will see that there is a flow of water from the from the glass that is on the higher height, and it goes to this glass where it is lower, height. And we say that this glass of water is on a higher potential. It has more potential energy than this glass that is on the ground. It has zero potential energy, and you can say there is a current flow of water from the high to the from higher to the lower glass. So let me remind you that let us remind something of ions. Ions are atoms that have more electrons than more electrons than protons, or more protons than electrons. So, example, if we have an ion that has more protons than electrons, and if we have okay, let's say 2, and we have a second ion that has, for example, 3 electrons and 2 protons. This one electron will try to, wants to flow here, and so this, so it will become an atom. They want to come in balance. So that the potential difference between two dots, between 2 points, is called voltage. This here we have an electrical voltage in electrical way, with electrons, with flow of electrons. That's why we say electrical voltage. This here you have here voltage, and voltage is the difference of higher and lower potential, plus or minus sign. But in electrical circuits, in electrical engineering, there is one problem. Well, that's not a problem, but it usually confuses people. We have here a battery, plus and a minus. Here is plus and here is minus. So here in plus you have a lot of protons, more protons than electrons, and here we have more electrons than protons. So we put the conductor. So we put a conductor over here, and a conductor, well, that's a material that has a lot of free electrons, and they can, they are capable for flow of electrons. So they have a lot of electrons. Here, minus, 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 minus. Electrons are negatively charged. That's by convention. There is no reason why, specific reason why electrons are negative and why protons are positive. It's by convention. That's more historical reasons. I don't know who I forgot who founded electrons. So electrons are going to flow from minus to the plus. But because of historical reasons, because Benjamin Franklin said that there is a plus and a minus sign, and that the plus is going to go from, the current is going to go from a plus to the minus sign. So it states that current, okay, maybe I didn't told you, but electrical current is basically marked as capital letter I. And it goes from plus to the minus. But the electrical voltage, because of this, goes from the minus to the plus side. And who causes these electrons to go from the minus to the plus? That's the EMF, electromotive force, and it's measured in volts. Don't be confused. In its name it has a force, but it's not in newtons. It's in volt. It's measured in volts. And electrical voltage, we usually from Europe mark electrical voltage as capital U. But I saw that Americans use this, that they mark electrical voltage with capital letter V. And it is also measured in V and V. And here the EMF looks from the minus to the plus, but also the electrical voltage. So the voltage is the potential difference of this positive and this minus sign, and EMF is the force that is going to try to move these electrons from minus to the plus side. Okay, so and one more stuff you can see, if you have a wider tube, there is going to be, a lot more current going through these tubes, and if you have thinner, then you have smaller. But so these tubes can give you some resistance, but you will see that in my next lecture. Thank you for watching. Click subscribe, like, and share to your friends so they can also learn about electrical engineering. Thank you for watching. See you in my next lecture.